Group 10 present you radius of investigation. Firstly, we will discuss about the definition of radius of investigation. Radius of investigation is defined as the distance of pressure transient has moved into formation following a rate change in a well. This distance is related to formation rock and fluid properties and the time elapsed since a rate change in the well. Some research prove that the time t at which a pressure disturbance reaches a distance, in this case is the radius of investigation itself, is given by equation followed. Different opinion on the numerical constant in the equation above is because of the formation properties might influence the response of a well in pressure transient tests.
Allow me to explain more on these two equations and the graph here. From the first equation, if we have a set of time, we can have a set of radius of investigation or the distance of the pressure disturbance propagated. From the first equation also, we can see that as time increases, the distance of the pressure disturbance propagated also increases. Let us move on to the next equation here. Actually, it is the same equation of the first equation, but it is written in terms of radius instead of time. And this equation also is valid when Ri is equal to Re, which is the drainage radius or the reservoir boundary. And known the reservoir boundary or the drainage radius, we can have the time for the disturbance, for the pressure disturbance to be stabilized. The graph here is generated by EI function, and it is to prove these two equations here. Assuming that this is your well bore, and you have a pressure disturbance at 1600 psi. From time equals to 0.01 hours to 1 hours, we can see that the pressure disturbance have propagated 10 feet from the well bore, and as time goes by, the distance will keep increasing. Meanwhile, let us look at the well bore pressure disturbance, the distribution of the pressure at the well bore. Initially, we have pressure disturbance at 1600 psi, but as time increases to 1 hour, the pressure distribution at the well bore drops to around 1400 psi, and the pattern continues as time increases. As we know, pressure will keep increasing until it reaches the initial reservoir pressure. And assuming in this graph, we have the initial reservoir pressure at 1800 psi, we can make a straight line here, and we can connect between the dots and the lines to have the graph. From this graph also, we can have our radius of investigation at different time. And if we extend the graph, we can also have our drainage radius or the reservoir boundary. This graph and these two equations have many applications, especially on well test analysis.
Radius of investigation has applications in well test analysis. As we know, well testing will analyze the transient pressure response due to the change in well rule. A qualitative use is help to explain the shape of a pressure build-up or drawdown curve. For example, a build-up test plot may have a complex shape at early times when the radius of investigation is in the outer zone near the wellbore where the permeability is different from the formation permeability. Radius of investigation concepts provides a guide for well test design by allowing you to estimate the time required to achieve the desired depth of investigation. Radius of investigation also provides a means to estimate the time required to achieve stabilized flow That is time required for pressure tension to reach the boundaries of a tested reservoir. Thank you for listening.